Hi class, this is lesson 12. Let's make me some money with some poker problems. So here's what we'll be doing. We're going to draw 5 cards at random from a standard deck of 52 cards. I'll explain that a little bit more in a minute. The number of possible hands or outcomes of the 5 cards is just 52 choose 5, and that's 2,598,960. Here's some poker terminology. Not going to advocate gambling, but you should at least know what I'm talking about here. There are 13 ranks. They either start or finish depending on the ace, and they run basically from 1 to 13, let's say. So the ace is either interpreted as a 1 or a 14. If it's a 1, then you have the numbers 1 through 13. If you interpret the ace as a 14, then you go from 2 to 14. But there's basically 13 ranks. 2, 3, 4, up to 10, and then the symbols J, Q, K, A. Jack, Queen, King, Ace. 13 of those. So there are also 4 suits. Clubs, diamonds, hearts, spades. 4 times 13, 52. So what we'll be doing is that we're going to be calculating the probabilities of obtaining various special hands that make us a lot of money. The first one I'll look at, and I'm just picking these examples out of the air, are what's the probability of obtaining 2 pairs. So for example, we could get an ace of hearts, ace of clubs, 3 of hearts, 3 of diamonds, 10 of spades. So I have a pair of aces, a pair of 3s, and I have a junk card. The 10 of spades doesn't help me at all. This hand does not include the possibility of a full house. I'll explain in a little more detail below, but a full house is a pair plus a 3 of a kind. So this is just 2 plain old pairs, no more, no less. So our task is to first select 2 ranks, ace and 3 in this case. We can do this 13 choose 2 ways. If I'd chosen the ace first or the 3 first, doesn't matter, because I'm still going to end up with a pair of aces and a pair of 3s. So order doesn't matter. That means I can do the selection of 2 ranks in 13 choose 2 ways. Now let's choose 2 suits for the first pair. So that's ace of hearts, ace of clubs. So how many ways can I pick those 2 suits? Again, it doesn't matter. Hearts and clubs is the same as clubs and hearts. That's 4 choose 2. I can do the same thing for the second pair, for the 3. I had a 3 of hearts and 3 of diamonds. I could have done that 4 choose 2 ways. Okay, so I've now taken care of my 2 pairs, the pair of aces and the pair of 3s. So I've sort of done my work with 2 of the ranks, and so that means 8 cards are kind of out of play now. That means I have 52 minus 8 equals 44 other cards that they're all equally awful, and so the remaining card, I can select that in 44 ways because they're all equally awful. Okay, so putting all this together, the number of ways that I can select 2 pairs is, multiply them all, 13 choose 2, 4 choose 2, 4 choose 2, 44. And that's 123,552. So the probability of 2 pairs is at 123,000 over the original 52 choose 5. Remember the 2,598,000. And that turns out to be about 0.0475. So fairly low probability, but still, significantly greater than 0. Fantastic. So we can play the same game with the so-called full house, which is, as I mentioned before, was equivalent to 1 pair and 1 3 of a kind. So for example, ace of hearts, ace of clubs, 3 of hearts, 3 of diamonds, 3 of spades. I have a pair of aces and I have 3 3s. No coincidence. So here's how you do it. First of all, I'm going to select 2 ordered ranks, because if I have a pair of aces and 3 3s, that's different than 3 aces and a pair of 3s. So 2 ordered ranks. I can select the first rank 13 ways, the second rank, given that I've already chosen the first, 12 ways. So that's the permutation of 13 things taken 2 at a time. Then I select 2 suits for the pair, just like I did before, 4 choose 2 ways. I need to select 3 suits for the 3 of a kind, the hearts, diamonds, and spades in this example. I can do that 4 choose 3 ways. Now I've run out of cards. I don't have to worry about that 44 from the last time. So the number of ways that I can get a full house is permutation of 13 things taken 2 at a time, 13 times 12. and then times 4 choose 2 for the 2 suits for the pair, and then 4 choose 3 suits for the 3 of a kind. So that's a total of 3,744 ways. The probability of a full house, again, divide by the 2,598,960, and that is a very low probability, 0.00144. So significantly lower, surprisingly lower than 2 pairs. The next example is called a flush, and all that means is all 5 cards from the same suit. And there are various different kinds of flushes. Some are actually a little more important than others, but I'm just going to say this includes all kinds of flushes, 5 cards from the same suit. So this is easy. Select the suit, 4 ways. Select 5 cards from that suit, order does not matter, 13 choose 5 ways, you're done. Probability of flush is 4 choose 1 times 13 choose 5. That's equal to 5,148 divided by the usual 2 million thingy, and that probability is 0.00198. Still pretty small. Now also look at what's called a straight, and this is 5 ranks in a row. So something like, here's where you can use ace as a 1 or a 14. So you could do ace 2, 3, 4, 5. Ace would be 1. You could do 2, 3, 4, 5, 6. That's a straight. 3, 4, 5, 6, 7, another straight. You could also have a straight 10, jack, queen, king, ace, where the ace is effectively acting as a 14. The point, though, is that you can choose the starting point for the straight in 10 ways. So that's 10 choose 1. That's the starting point for the straight. Anything from ace to 10 will start that straight off. Okay, so then you can choose an ace 4 ways. You can choose a 2 4 ways, a 3 4 ways, etc., etc., etc. So select the suit for each card in the straight. You can do that 4 to the 5 ways because you have 5 cards in the straight, each one of which can be chosen 4 ways. Therefore, the probability of a straight is 10, the starting points, times 4 to the 5th, selecting a suit for each card in the straight. And that mess turns out to be 0.00394, a little bit higher probability than the flush. Okay, one last thing I'll do. I'm going to put those last 2 together. Let's have a straight flush. And what that means is you have a straight, like 1, 2, ace 2, 3, 4, 5, but they're all from the same suit. So how do we do that? We select the starting point for the straight 10 ways. We select the suit 4 ways. So the probability of a straight flush is 40 over the 2 million mess. And look at that tiny, tiny probability. These are very, very rare. Okay, great. So this gives a small compendium of the different types of probabilities that you can calculate in poker, and now you can go out and win millions and millions of dollars. With that in mind, you could also maybe do bridge problems or Yahtzee problems. They're a little bit different, but they do apply the same techniques, so they're not too bad. Okay, great. So at this point, we've gone through several lessons involving counting probabilities, counting problems, and now we'll graduate on to a different set of problems involving a conditional probability, independence. Those are coming up in the next few lessons, and they're very cool, and I'm sure you'll be looking forward to hearing about that. So again, see you soon.